Hi everyone, welcome back. So today my topic for this particular video, like how we can develop a chatbot, a app with advanced RAG. In this particular video, my focus is to improve performance of our RAG system. And in this particular case, I'm going to use Llamaindex to develop our RAG system. And from the LLM perspective, I'm going to use open source LLM Mistral 7 billion. And to deploy our RAG system, I'm going to use Flask for the API point and UI point. And also I'm using the lane chain here. So let me start with basic about the like how in this particular video I'm going to improve our RAG systems, like how we can develop a app with advanced RAG. So if we talk about like how a basic RAG system is work, actually I already cover the basic RAG from the beginner point of view in my previous video. If you have any doubt related to RAG, like how we can develop a RAG from scratch, then you can refer to my previous video as well. So in this video, I'm going to improve the performance of RAG system. So in generally in RAG system, when user asks a query, those query basically go to our RAG system. And on the very first step, those query convert into the embedding format by the embedder model. Then our retriever basically retrieve the best match, find the best match as per the our search engine or search strategy, best match from the vector database. So here in the vector database, we have our domain information in embedding format, and our query also convert in embedding format. Then our similarity search or our as per our strategy, search strategy, our retriever basically find the best match from our vector database, then retrieve those context to LLM, and then LLM generate the response by using the prompt query and the relevant context from RAG. Then LLM basically generate data by using these three information. One is the prompt, second one is the query, then the relevant context, and then generate the appropriate response. But here we can improve our RAG system. Our goal is to improve our RAG system. Then how we can improve? We have the two option here. One is the pre-retrieval optimization on this step. When our retriever search basically going to vector database to find the relevant context, best context from the vector database. On this step, we can optimize, we can improve our RAG system. First one is the pre-retrieval optimization. Here we can use the auto merger, sentence window, different strategies. I'm going to discuss later in this particular video. Second option, like after the search, we have the post retrieval. This strategy we call the pre-retrieval. Then we have the second option is the post retrieval. Now we have the context, like our system find the context from the vector database. Then we need to filter out the best context, like best context. Then we send those best context to our LLM. So here in post-retrieval optimization, we can use again sentence window, Reranker, multiple strategies. These strategies we are going to discuss in this particular video. So in this particular video, I'm going to discuss the pre-retrieval optimization, like how we can improve our RAG strategy by pre-optimization. Like pre-optimization, basically how we can enhance our chunking strategy. In my previous video, I cover RAG from the beginner point of view, on which I discussed the document loading, chunking, embeddings, vector database retriever. So in this video, my focus on pre-retrieval optimization, like how we can enhance our chunking by using the sentence window. And then we going to discuss the post retriever as well. So here in the post retriever, like we add some strategies to retrieve sentence window along with re-ranker. So this is the goal of this particular video, like the pre-retriever optimization, post-retriever optimization. So let me discuss this part and start with the pre-retriever optimization first. And we have the multiple options for the pre-retriever optimization also, like we can use the sentence window retrieval. In this particular video, I'm going to discuss the sentence window retrieval with sentence re-ranker, these techniques for optimization of our RAG system. Another strategy also available, we can use the auto merging retrieval along with sentence re-ranker. And in this particular video, my focus on the first strategy only. In next video, I'm going to cover the auto merging part. So this one is the basic about the rack. These things I'm not going to cover in this particular video. This basic nav approach I already covered, like how we can develop a rack from document loading to the vector database or retriever in my previous video. Here might focus only on to improve the performance of our rack system. So now I'm directly jump to the sentence window retrieval. So here basically I'm going to use this sentence window retrieval for the pre-retrieval optimization. So how this sentence window retrieval basically work? In sentence window node parser. Node parser basically the same chunking. In the lane chain case, we call generally this chunk strategies. In case of Llamaindex framework, we call this the node parser. Just the terminology. Node and chunk both are the same things. Node, chunk, sentence, those are the same things. So how this works? It basically divide a document into the chunk part, into the sentence part. This is same as we discussed in our previous video as well. Like we perform the chunking. Same way this sentence window retrieval work. This basically divide a document into the small chunk. And then we have the window. Then window comes into the picture. Window basically generate a context window. And if we provide the size of 3, then it basically create a context window of 3 chunk. Let me explain these things with the help of this diagram. So as shown here in the diagram, suppose this is my document. So in RAG system, first we load the document. So here again, we are loading our document, then performing the chunking. And chunking with the help of sentence window retriever, as I explained in previous paragraph. And we are providing the window size 3. So you can see here in the document, we have the around 5 sentence. So by default, a chunking strategy divide these document into the 5 sentences. You can see here sentence 1, sentence 2, sentence 3, 4, and 5. And window basically sentence window retriever basically generate a window. We provide the window size, for example, 3, then it generate a window. This green part is a window along with the sentences. This is the window. And we provide the size of 3. So this window basically size of 3 chunk here. So ask for any query. For example, here the query, what are the common threads or what are the threads for marine ecosystem? Then our retriever go to our chunk data, our vector database. And from our vector database, it find the best match and then retrieve the best context. This is how the retriever is work, RAG is work. But here, like the best match would be for this query is sentence number 3, as I highlighted this into the red color. This is the best match as per this query. But we are using the window, sentence window retriever. So it basically retrieve 3 sentences instead of sentence 1, like sentence 3. It retrieves sentence 2, 3, and 4, combination of 3 sentences, because we are retrieving the window. And this is the way how we can improve our RAG system. And this strategy depend upon our business problems, like what kind of data we have, what kind of format of our data we have. For example, if we have the PDF, in the PDF we have the different tables, or if we have the chart, or if we have the simple textual data. So these strategies change as per our data, as per our business problems, as per the technical problem in hand, like the data format issue. But this is the one way. Like in simple chunking strategy, we retrieve single chunk. But here basically we add 3 chunk in a window, and this is the one way how we can improve our RAG system. So this is the high level overview of sentence window retriever. And now I move to the coding part, like how we can implement this. So to implement this thing, we need to change our code, or we need to use this code in two parts. One is the pre-optimization of our RAG. In the pre-optimization, basically for the chunking part. So here we are using the sentence window node parser, and we are importing this from the Llamaindex core node parser. From here, we importing the sentence window node parser, and then we are defining our sentence window node parser. along with this parameter window size and window metadata key and original text metadata key as well. And this is our node parser now. And so this is the pre-retrieval optimization. And here basically we are using the window in the chunking part. Now we need to add the same functionality into the retriever as well, so that retrieve can retrieve the window instead of same simple chunk. It retrieve a window. So here the metadata replacement post processor come into the picture. We can add these metadata replacement post processor to our query engine. Then our query engine basically retrieve the window. So this is the code. You can see here we are importing our metadata replacement post processor, and then we are defining our post processor here, and we are providing the metadata key is window because we are interested into the window. If we are interested in original text or simple chunk, then we can provide the original text as well. Here the key. So after the metadata replacement post processor, we have the another strategy as well to optimize our retriever, like to optimize the post retrieval. Here we are using the sentence transformer reranker to optimize the post retrieval. And how this works, like in the RAG system, our query is come, then our RAG basically retrieve the best context. For example, if we provide our parameter is similarity top case 6, then it basically retrieve the top 6 match. For example, this is the context 1, context 2, context 3, top 6 context. You can see here. Now further we can use a re-ranker. In re-ranker, basically we are using the LLM here also to re-rank the context and to find the best context from the retriever response. So retriever basically retrieve the 6 context. Then we use the re-ranker model. Re-ranker model again AI model, and then we use here again. You can see here it here we use the p parameter 3. So it basically find the best three. It basically perform the re-ranking, find the best 3 context, and then retrieve the best 3 context to further LLM. And then LLM generate the response by using these best context, prompt, and query information. So this is the way how we can improve our RAG post retriever part. So let me jump to the coding part now. And you can see here we are using the model. This is the Reranker model, and we can provide the different model as well, and we can deploy local model as well. Like we can deploy local model on our local machine, and then we can use those model as well as a Reranker. And this is the our retriever. This is our retriever. You can see here we are using the as query engine, and we are providing the similarity to k parameter value, and then the post processor. In the post processor, we are using here the post processor from the metadata post processor for the sentence window retriever, and this is the re-ranker. So this way basically we can improve our RAG system. Now I'm going to discuss the whole code. Like we are going to develop a chatbot with sentence window retrieval and re-ranker transformer. So here first we need to load the document. So in every RAG system, first things we need to load the document. So here basically we are loading our document. You can see here we are loading our document here. So this is the document loader code. Then we need to perform the chunking. So chunking and node is same thing. Node parsing basically. So here we are using the sentence window retrieval. As I explained in the previous section, we are providing the window size, metadata key, original text key, window key, all things. And then we are developing our vector database. And in Llamaindex, basically we called is the index vector database, and index same thing. So here basically we are using the OpenAI, but we can use the local LLM as well. I will show you in Visual Studio Code. We are using the local LLM as well. And here we are developing our vector database. You can see here we are creating the service context, then we are creating our vector database. This is the vector store index, is the same vector database we discussed in our previous video in the lane chain, where we where we use basically the Facebook AI similarity search. Yeah, I think Facebook AI similarity search or Chroma DB, but here we are using the vector store index. This is the same vector database. Now we need to develop our post retriever strategies. So we are adding the meta replacement post processor. You can see here. This one we already explained, and then the re-ranker. You can see here. Here we are adding the re-ranker. Now we are utilizing these re-ranker and the metadata post processor all information into our retriever. You can see here, and also providing the similarity top key value and top top n value 2. Here we are providing the top n value 2 for the re-ranker model. And now our engine is ready. Our retriever engine is ready. Now we can ask any query and it basically retrieve the best match as per the query. So this all code basically I explained to develop a chatbot, and this is the overall code. Now I'm going to show you the GitHub. So this is the GitHub link. You can find all the code. And I will provide the GitHub link and this blog link in the video description as well. You can find all the information. And this is the GitHub link. You can directly download all the code on your machine and you can use. And here you can use the open source LLM as well. You can see here we are using the 7 billion Mistral. You can use this LLM as well, and I will provide the all the instruction in the README file. You can follow this README file on the GitHub to set up this same application on your machine. And hardware requirement minimum 8 GB is required to run this code. And let me show you in the Visual Studio Code. So you can see here. Here basically we are importing the Flask. So Flask to develop our APIs and UI part, and Llamaindex for the retriever part, and lane chain basically we are deploying the local model with the help of GPT for all. That's why we are using the lane chain. From the lane chain we are calling the LLMs. And we can use Ollama as well. So in next video, I am going to deploy a local LLM with the Ollama. But in this particular video, I'm going to use the GPT for all. So now first we need to develop uh, our RAG system. So here are the first method. In this first method, basically we are using the chunking. So chunking basically the node, as I explained in the previous section also. Like the chunk and node both are the same thing. In the lane chain, generally we call this the chunk. In the Llamaindex, we generally use the node parser, node terminology. And here we are developing our service context, and then uh, you can see here this way basically we are developing our RAG system. You can see here basically the sentence window node parser, same code which we explained in the previous section. Here we are providing the window size is 3. In the previous section also we discussed the window size 3. Then we are defining our service context. You can see here LLM model, embedder model, and chunker, all the information here. And then developing our vector database. You can see here, this is the vector database. Here we are loading the document and service context. And then we are using the post retrieval optimization like the metadata replacement post processor and the Reranker. You can see here same information in this method. And then this is the final retriever system. And now we are going to load the document, then calling the above methods, basically above functions. You can see here basically we are calling the above functions, and this is the local model. You can see here local model, and as per the RAM availability, yeah, in case of Mistral 7 billion, you require the 16 GB RAM at least. If you have less than 16 GB, then you can use this small model. This is the 3 billion model. So this model would be run on 8 GB. If you have the 8 GB, then you can use this model as well. This is also local model, and this is the way we are developing our RAG system. Now I'm going to show you the UI, like how the UI is working for this. So this is the UI part for this RAG system. Now I'm going to ask a query like how can I learn How can I learn AI? So this query basically going to our system. Let me show you. Yeah, you can see here. This query is coming. So it will take few seconds to respond because same LLM is working on this particular machine. On this machine, I'm going to record this particular video. So that's why it will take few seconds. So till the time I'm going to explain you Visual Studio Code. So this is the advanced RAG app. This is the overall code of this RAG system. And for the UI part, we have the template bot_1 HTML. You can find this old code on the GitHub as well. And for the data, I'm providing this ebook, PDF ebook, and this textbook for our RAG system. And this index, this folder would be automatically generated once you run this code. Llamaindex basically create this sentence index to store the information on local system. You can see here. Here basically we are storing this on the local drive. Let me show you GitHub. Yeah. Okay, you can follow the readme instructions. You can see here, you can follow the installation instructions from the readme file, and you can easily set up this app on your local machine. And this one is the main file. This one is the main file. And to set up a local model with GPT core all, this is the file and data. Here in the data folder, we have the data. For the UI part, we have the template here, and this is the README file. These are the requirement dependencies file. So this way you can easily install, easily set up all the code on your local machine. I will provide this GitHub link and this blog link also in this particular video description. And if you have the queries like from the beginner point of view, like how we can develop a RAG from scratch, if you don't have any idea regarding the RAG, then you can refer to my previous video. In the previous video, I explained the RAG from the very basic, very beginner point of view. Like I explain each step, like how we can upload the document, how we perform the chunking, how the chunking is work, then the embeddings, then vector database, then retrieval, all things in detail in my previous video. And let me go to the LLM. So guys, please like and subscribe my channel, and I'm going to create more video related to generative AI, Gen AI, multimodals. Multimodals basically the same model work on the images and text data, and also the how we can productionize our model by using the LLM ops best practices like from the CDCI pipeline to the evaluation, multiple model selections, and prompt engineering also. So I'm going to create more video related to this topic. So please like and subscribe my channel. So you can see here now it's responding, but yeah, definitely it take a few minutes because of configuration of my machine. So as I mentioned earlier, also like at least you require the 16 GB machine to run these model on the locally. Yeah, definitely. If you have the 16 GB machine, you can easily deploy this model on the locally, this app on the locally. And in my upcoming video, I'm going to deploy model LLM and VLM as well. Like the VLM, basically the multi-model. Those work on the vision part also on the local machine with the help of OLAMA. So please like and subscribe my channel, and thank you watching for this.